let me quickly see what's up. My own channel. I don't know why I'm looking at it. Footer. Okay. Okay. Hello, Royaloff. Slides. Hello, Hill Hunter. Okay. Today will be a very short lesson without Kahoot as well, and the homework will be announced tomorrow. Hello, Dave, 9 to 4 Punk. Here are the slides. Hello, Joshmond. You did not miss anything. And I hope you had a nice meal, Aurora. So let me know if you guys hear me well, and we can start. Oh, that's nice. I did add a few filters on my voice, so you shouldn't be hearing too much static noise. And yeah, it's quieter for that reason, because I don't want to pick noise in the background as much as I did before. So now when I'm silent, you shouldn't hear noises, at least, which is good. So today's agenda is to talk about extension methods, or how to add methods to code that doesn't belong to you. Only some methods, some kind of methods, and you'll see what kind of. And the second part will be talking more about the guidelines for methods input, output. When should you use abstraction and when you should not? And we'll talk about IEnumerable a bit more. So let's get to it. We'll start with extension methods. So sometimes we want helper methods. So we make helper method which takes a string or a person or something else, and we work with that thing. But sometimes it feels that it would really suit as if we could add that method in the class itself and call it from the object itself, not pass it as an input, but call it from the object itself. And there is a way to do that, and that is called extension methods. So here's an example of what I mean. Name is a string. And here I say that string suddenly has a method to Pascal case. Of course it doesn't have this method. That's just something that I made up. But you can make things up like that through extension methods. So how do you do it? And there are two parts to extension methods. So extension methods have to be in a static class. So they're static methods essentially. Static methods in a static class, and the first parameter needs to be with a this keyword. And as long as you mark the first parameter with this keyword, uh, the type that the first parameter is of will uh, be treated as if it was its own method, the extension method. So string now, this string will mean that I'm adding an extension method to a string. So this is the implementation for that method that allows me to do to Pascal case for text, for string. It's nothing very difficult. It's certainly very useful because we constantly face limitations of libraries because they don't want to make, like, it's impossible for them to make something that works for everyone uh, exactly the way they want. And therefore, we can make our own extension methods and just quote unquote fix it or fine tune the methods to fit our own needs. Personally, I use this quite a lot, and especially when I need to do some testing, because testing frameworks often don't have all the assertions I want. For example, what if I want to check if I can construct an object from a file? And there is no kind of assert like that, but it's quite useful for testing purposes. So I make an extension method to the testing framework, assert method, that I check if file can be uh, if we can build an object from a file. Um, Dave94Punk asks, so if I have this float number in brackets, I would create an extension method for floats. That's exactly right. It's as simple as that. This and then the type you want to extend. All you have to do is to put this in a static class in a static method. If the class is not static, but the method is static, it will not work. So you need to consider that. All right. And you can make an extension methods for everything really. You can make it for classes. You can even make it for interfaces. So um, in order to share behavior across interfaces, you don't have to um, create an abstract class, for example. Another way would be to create an extension method. And through extension methods, you could share behavior across interfaces. For example, if I have a list of people, and you know that there are different kinds of lists. There is a read-only list, there is a list, there is a blocking list, and so on. So if I want to generalize that, I could then just say that I write an extension method for iList, and then all the different lists will now support my method. And this method, I think, should go by default for every project because we nearly always need to print the contents of a collection, of a list, of an array, etc. And it isn't done for us. If we do the string for a collection, it will print its type, but we don't want the type, we want the contents. So this is an extension method, which basically works for collections of iList type. And we'll show how to make this even better in live coding. And again, it's a generic list. So for every generic, this still works. Another cool thing is that for a specific generic, I can also specify what for what generic specifically I make an extension for. And that will also work. But then I don't need this, and it will not be generic anymore. And the craziest thing of all, we know that enum doesn't have methods, but with extension methods, we can even add methods on enum, which makes no sense and I see no need of it, but it's quite cool to play with it. So here you can see we have genders, male, female, and other. And we have a get name function, like we pick a name based on gender. Oversimplified, of course, but we basically say gender dot other and then get name, and it gets name of other. Pretty nice, right? Not very practical. I wouldn't recommend using it, but it's just something for your interest. If you do need it, you can do it with extension methods. So it's like a trick question that someone might ask you. Before we move on to the next chapter, to the next part more like, do you have any questions? Questions about extension methods? Because there is nothing more to it than that. It's quite simple. If not, let's move on. What if it overlaps with name? If you mean if class name overlaps with the class that you extend to name, then you should always, by convention, write the suffix extensions for the class that you extend with extension methods. For example, if I write extension methods for a string, I'll write string extensions. If I write an extension methods for person class, I'll write person extensions. Now, if you refer to what if it overlaps with existing implementation of other methods, such as, for example, if you want to make your toString method, right, and you make an extension method toString for a list, it won't work. It will ignore it. It will prefer the one that comes from the type natively. However, if you can still call that method as if it was from a static class. So from extension class, you can call the extension method as if it was just a static method. Yeah, so that's exactly what I answered. Hell Hunter Max. It wouldn't work. You can still call it for static class though. Next, so some guidelines about input output and method body in general. So first, prefer to get and return something as general as possible. If getting and returning general stuff does not change implementation, you should do it. Generalize stuff if it makes no difference in the implementation of method. As long as you accept as many things and return as many things as possible without having extra complexity, you should do that. So use an abstraction. Prefer to use an abstraction in input and output, because it also makes the intention more clear with what you can actually work and what is the minimum that you need. Next would be the next step would be to not to use generics if you don't actually utilize generics. And this is actually sometimes, even a senior makes a mistake like that sometimes, without putting too much attention or forgetting what is the purpose of generics. So for example, if I'm logging something and all I need is to call toString, toString exists for every type. It comes from object. So everything has toString method. So if I need toString, then I don't need generics because I don't utilize the genericness of a variable of input. So if I have a generic method to log something, I definitely don't need that to be generic, because anything goes and I don't treat it explicitly with the type that goes in. So I can simply pass object. Having generics where it's not needed doesn't make things that bad, but it's just unnecessary confusion and complexity. So don't use generics if you don't need specific types. And don't return a list or array if you're going to iterate through it only. In C#, we have a really nice data type for overall something that needs to be iterated through and holds many items. So an array, a list, a key value pairs collection, it can all be generalized to IEnumerable. And IEnumerable is a type which basically says iterate me through. That's all it does. It doesn't have an index, it just supports for eaching itself. So here, let's move on to the next example. Here you can see people filter. And here you can see that to people's filter, I can pass any collection of people. So maybe the use of it. Let's first start from the use of it, and then how it's done we'll see next. So here you can see we have a list of people and person array, right? So people list, people array. And each of that has a single person, which is a detail. It can be many people, it can be no people, doesn't matter. But it's a list and array. Two different data structures, very different data structures. And yet when you look at what method we call the same method, which takes either a list or an array. You might think to yourself, hey, that looks like an overload. But in reality, it's a single method, which takes IEnumerable, a generalized form for both arrays and lists. So all I needed was to filter. So all I needed was a for each, and here you go. I used the for each, and every person passed through a predicate filter and added it to a qualified people's list. And yeah, IEnumerable supports a ton of extension methods. It's like all that you can think of. And most importantly, the biggest feature of all is something that I will not say today. Let it be a teaser. I'll mention it. Actually, I'll talk about it for the next 2 lessons on Saturday and on the next Wednesday. For 2 lessons, we'll be talking about a huge feature that IEnumerable has. A huge feature that you'll be using in every single C# project that you have. So huge that it's important to learn it and learn it well. But for today, that's all I'll say about IEnumerable. It's just a generalization of a list or an array or other collection that stores many things. So to summarize that point, if you can return, like if you return something with intention to be just read and not processed otherwise, use IEnumerable. Yes, use IEnumerable when you return or get something instead. If you need to, like if you take something as input with intention to add, like to change it, then it's fine to take it as a list because it will change and IEnumerable will be just a complexity. But if your intention is to read something, you should not you should use IEnumerable and not a list. You cannot index IEnumerable. You can only for each it. It can only be iterated through, but it doesn't have an index. Like it's the most lightweight collection to work with. It's perfect for filtering, but it's it doesn't work when you need to add or remove items. Like if you need to modify an enumerable, you might consider returning something else. However, if you have some public API that returns something that you expose to someone, return IEnumerable, not a list, not an array. Array should never be returned, in fact. It's the worst thing that you can return because it's basically like IEnumerable, but doesn't have any benefits. Array should ever be used in some optimization problems or internal method implementation, but list and IEnumerable are the two things that you should be using. You can index an array, but there is no point of it that much because you want to generalize your output. And by array, you just specify that it's always array. It's change proof, essentially. And by having an abstraction over implementation that you return, means that others can easily consume it. You cannot easily consume an array when half of your application is IEnumerable based, the other half is list based, the third half is dictionary based, and so on. However, you can consume IEnumerables easier for many, many, many reasons. And you'll see what are those reasons. In the next lesson, again, one more tease. Now, guys, please write one thing that you think you understood well and one thing that you'd like to understand better, and I'll be right back in a minute. Okay, Roloff said that he understands very well how to use extension methods and IEnumerable both very well. This was a very easy lesson compared to the last two. That is true, just like I promised. It's a very easy lesson, but a lesson that needs to be taught nevertheless. Anyone else? So Catgirl Aurora said, I'm wondering how the extension classes works under the hood. I guess it compiles stuff to work at runtime, but wouldn't it in a way need to check through all static classes if type can use an extension from it? Under the hood, it's just a static method. So you basically still call a static method, but just with syntactic sugar. It's a static method, just with a different syntax. You can still use both methods, both static and non-static versions of it. Let's use IEnumerable, another example for IEnumerable because it's a more interesting one. And let me demonstrate to you one thing also about the extension methods. So for example, we have this string extension, you see. String extensions to Pascal case to convert text with first letter to be upper and the rest to just go as it was before. So for example, we have my name, and then we have the Pascal case, and we right line it. Let's just call that one. So we run the demo, And you can see my name got Pascal case basically, right? But there is one point that is also nice to know, that I have a choice, an option to call it slightly differently. I can also call it as if it was a static method. So first let me clean up slightly, not clean up, but just to put it side by side. So instead of name, I'll now say string extension to Pascal case, and I pass in the name. And you'll see that it's the exact same behavior. So you can either use it as a static method, or you can either use it as something that comes natively from an object. And one more example that I like to show is that the string example, the ambiguity. So if I go back to my iList extensions, and if I say to element string, and instead of elements, I just say string, right? And then I go back to program, and then I go back to iList demo. So here you can see the string. Right, so since I'm using extensions, it picked it up and it seems to prioritize this time. Okay. So it actually printed what it should have. So it takes priority actually over the string. So you can do just the string, but it's a bit weird because you get this ambiguity, and if you, in case you forget to include this namespace, you'll have a different behavior. Yes. So it's like if you do this, it will work, but I don't know if I wouldn't recommend to do this. Because you might have different unexpected behavior just because you mixed up namespaces. Which is one more way of introducing a bug. Okay, Catgirl said, how does it assign something inside the call parenthesis? What do you mean? I'm not sure what you mean. Joshman said, so if you do create a method that takes on the name or the same name, make sure it has its own namespace. That's right. Okay. You had write line name to Pascal case, assigning the name inside the call of write. Oh, did I? I see, I did. It is a valid statement. Again, I did it by accident. I wouldn't do this. It's valid, but I wouldn't do this. Yes, of course, I can do it without. So yes, it printed the name in both ways. Okay. Now, let's make a practical example. Like, why would I want to pass iList for the filter of a string? Why would I want that? It's not very practical. I want to pass IEnumerable. Actually, not this one, but the extension method for iList. Why would I want to print all elements of just iList? I might want to print all elements of an array, of a list, of something else. So I want to be I want the string to be as broad as possible. So I list extensions. And this is actually IEnumerable extensions now. So let's rename it to such. Okay. So my goal is to write a method which could print all elements of array or a list, both. So all I have to do is to accept IEnumerable. So if I go here now, okay. And here you can see we have words as a list, and let's have words as an array. One and two. And I'll say that we write, maybe we want to add one more method to make it even more easier. So to print everything. So the string and print public static void print something that is generic, that comes from a generic IEnumerable T, and that is many or just items, which makes more sense. So it basically calls the string for items, and it just console.write line is this. So it's definitely a useful method to have. And I'll rename instead of list items. Okay. Great stuff. Awesome. Now let's try to use it in a demo. So we have words 1, words 2. Let's print all words in the console. So I can now say words 1 print, words 2 print, and each will be printed to a console which they were not. First, the questions. Why IList and not just list? You should actually always use IList. Yes, you should always use IList if you can. When you return a list, you should return IList instead, as it is some sort of an abstraction, as it gives you slightly more options. And preferably IEnumerable altogether. Now, why is this not working? We have the string. Then the string items. Oh, because I don't call it, that's why. Makes sense, okay. So you can see that this call was done twice, and first time with a list and second time with words. In this case, actually, list is a better thing because I am still working internally inside the method, and it's really unlikely that I'll need different kinds of lists within this method. So it's okay to have this as a list instead of IList. you don't need to explicitly have something when you work with internally, some abstraction, if it doesn't benefit you. But when you expose the some data, some properties, some method, it should always try to be as abstract as possible, um, as long as it doesn't introduce any complexity. If it doesn't introduce any extra complexity, try to make it as abstract as possible. So here you can see words 1, words 2, a bunch of words printed. A really useful method for extension implemented via extension methods. Because now if I want to print any list or any array, all I have to do is print. So this would even work with printing people as long as they implemented the string override. So yeah, that's it. That's all I had for this lesson. If you have any more questions, I'm free to answer. If not, I will have to say goodbye for this day. Homework will follow again tomorrow. About group projects. I have a few ideas, and it's going to happen. It's going to happen quite soon. It's cool ideas as well. So again, I'm just teasing you. I would really like to have a meeting at some time. Sometime this week, preferably. Maybe on Friday. So I will first try to gather times of availability of everyone, and then decide on the time for each team to come on Discord and have a talk. Do a little team building per se. Because I would like to know the people more and understand or potentially see if they would synergize together or not. So that needs to be covered before we can start building teams and dedicating time for them. And the topics, of course. I will say though that what you will guys be doing, at least one team, is something that will not be a toy project. It will be something useful. And you will actually probably have a client. It's not paid work, don't worry. It's good. Well, so one more thing to mention about teamwork. For teamwork, we'll do it in agile way. I'm not sure if anyone knows about agile. For agile, so I'll try to teach for one lesson, maybe after we're done with lesson 3, not lesson 3 but chapter 3. I'll have 2 extra lessons in between to talk, one about teamwork and agile, how agile workflow is going. What is agile? Agile is basically the most popular workflow that there is for work. And the second one is how to plan stuff, about drawing diagrams, making specification, documentation, stuff like that, planning stuff. So I'll have 2 lessons for that. And yes, Scrum. You'll have your own board, you have your own project repositories, your own task board, which will look something like let me see. Yeah, sure, we can go there. let's say here, something like, no, here, like this. So this is the board that you will have. Not each, but per team. And basically, drag and drop stuff around. The project will not be the CSN website. Definitely not. It's a bad idea. It will be something more useful. Yeah, so GitHub repository with standards and stuff like that as a separate project probably. So there's a lot to do, a lot to expect. I hope you're hyped. I'm also hyped. You'll have mentors who guide you through. Probably one mentor will be like a product owner, someone who will guide the process. One or a few, or me, I don't know yet. Yes, mentors will supervise and code review your code, don't worry. I will do that at least for sure. Um, no Kahoot Deco, Roloff. You will review each other. That goes without saying. But um, there will be three reviews requirement. At least 3 reviews. Ideally, 2 team members and one mentor, because you're still very inexperienced and you definitely need a second pair of eyes, because it can go off the rails quite easily, the code that you write, and it needs to be checked because we want to make this really nice. Again, I won't say what it is yet, as I don't know specifically myself, but I'll just say that it's useful. So have big dreams, expect teamwork, expect being useful, expect learning a lot, and expect that the project that you'll do will sit very well in your CV for applying to a job. It's not going to make money. Yes, this will be a nice portfolio piece, and with this piece you can land uh, a job quite nicely. Yes, that's closer to what Hellhunter said. Let world become a better place. Okay, so that's it for this lesson. Thank you all for watching, and see you next time.